Hey everyone! Today, we'll walk through adding Linux worker nodes to a Kubernetes cluster using kubeadm. This is especially useful in a real-world scenario where you need to expand your cluster for higher workloads or to add redundancy. Imagine you're working for an e-commerce company, and it's a busy sales season. To handle the increased traffic and scale your application, you need to add more worker nodes to your cluster, distributing the load efficiently. Before adding a worker node, a few prerequisites are necessary. Ensure your new node has a compatible OS, we're using Linux here, sufficient resources, and network access to the Kubernetes control plane. You'll also want to install Docker or any other container runtime your cluster uses, and disable swap, which is a common requirement for Kubernetes. Once that's set up, we can install kubeadm, kubelet, and kuberctl on the worker node. You can do this using package managers like Yum or Apartment. These tools will help you join and manage the cluster. If you don't already have a control plane set up, you'd initialize it on the main node using kubeadm init. This generates a join token that you'll need for adding new nodes to the cluster. In our scenario, we assume this is already done, and we'll focus just on adding the worker nodes. Now let's move to the worker node. We'll use the command provided by kubeadm init from the control plane. It looks something like this: kubeadm join control plane IP 6443 token discovery token cassert hash SHA-256 hash. This command connects the worker node to the cluster by authenticating with the control plane and synchronizing the node configuration. After running the command, you should see a success message confirming that the node joined the cluster. Kubernetes will start the processes needed to allow this node to run workloads as part of the cluster. Back on the control plane, we can check if the new worker node was added successfully by running kuberctl get nodes. This command lists all nodes in the cluster along with their status. You should see your new worker node listed as ready, which means it's prepared to handle workloads. In our e-commerce scenario, this extra node capacity can now help handle user requests more efficiently. Kubernetes will automatically start distributing pods across available nodes, improving resilience and performance during peak traffic. This approach is not just for emergencies, you can use it to scale out your application for any high-demand scenario or to prepare for scheduled high-traffic periods. It's also a great way to test your application's resilience and observe Kubernetes load balancing in action. And that's it. You've successfully added a Linux worker node to your Kubernetes cluster using kubeadm. Thanks for watching, and be sure to subscribe for more real-life Kubernetes tips.